Hi, my name is Harisa and I'm doing an MSc in Computer Systems Engineering from the University of Glasgow.
I'm Santhosh. I'm doing my Master's in Telecommunication from the University of Glasgow.
We would like to share with you what we learned in our course, Digital Signal Processing by Dr. Bernd Porr. What we basically did was we took ECG samples from the students and then we used MATLAB to remove the 50 Hz noise from the signals. We used different techniques and today we're going to talk about two of them.
I'm going to record an ECG signal from Harisa using these electrodes here and the instrument here. I'm going to put one electrode to her left arm and put one electrode to her right arm. One to her right leg and the last one to her left leg. What these electrodes do is they pick the ECG signal from a body and they're going to be transmitted to my system using these equipments here. That's the ECG signal, which doesn't look like one.
Yeah, because there is a lot of noise.
Which is basically the 50 Hz noise from the AC components which we are using. So what I'm going to do is I'm going to clip a part of this ECG and I'm going to process it in non-real time. Whereas Harisa is later going to explain you how to do it in real time. So there I go. I got a part of the ECG signal from Harisa, which looks like this. Now I need to check which frequencies the noise exactly lies.
Mm-hmm. So you're going to do an FFT?
Yeah, which is the fast Fourier transform. In MATLAB, it's so simple. Just FFT of the signal, and I get the signal like this, which shows the frequency components. At
the 50 Hz, we can see a peak.
Yeah. So there are two peaks, which are like the 50 Hz noise, which can be seen from the index numbers. Mm-hmm. So the 50 Hz noise needs to be knocked out.
Obvious.
I'm going to use the index numbers of where the 50 Hz actually lies, and I'm going to just put 0 there numerically.
Okay.
Okay. I can see the FFT of the signal with with the two peaks removed.
Obviously, yeah. Okay.
To see whether this 50 Hz is really removed, I need to go to the time domain, which I'm going to use. I do the IFFT of the signal, which is nothing but the inverse Fourier transform. Okay. There I go. I've got a better signal.
Yeah, and you can see all the peaks, the P, Q, R, S, and T.
Yeah.
This was just one method of doing it, because Santhosh actually used the frequencies and he knocked the frequencies out. So if we have to do this in real time, what we're actually going to do is we're going to use FIR filters, the finite impulse response filters. We're actually going to build an impulse response, and just like how Santhosh knocked off frequencies, what we're actually going to do is we're going to have ones for the frequencies that we do want in our signal and zeros for the frequencies that we don't want. So in this case, I'm going to knock out the 50 Hz frequency, and Santhosh over here would build me an impulse response. If I do an FIR filter on my ECG in real time, yeah, and this is the result that you see. What you now see is that because of that filter, all the 50 Hz noise has been removed in real time.
There you go. We can see both the removed 50 Hz noise.
Yeah. Okay. And this was very simple.
And this is what we learned in the course.
Yeah.
Basically, this 50 Hz noise interference is going to be there in all the equipments which has sensors and using the AC power supply. So this is like the basics of what is there for the signal processing.
And it can come in pretty handy as well. Thank you.
Thank you.